Alright, so I think I'm recording. We've been looking at rational functions, and we're trying to look at the end behavior of rational functions. Rational functions are a ratio of polynomial functions. The numerator and denominator are both polynomials. To determine the end behavior of this rational function, we want to compare the degree of the numerator against the degree of the denominator. So here I look for the largest exponent on my variable because it's written in standard form. You can see the exponents are descending order, that this degree is equal to 4. Now, this one's not in standard form, but it's not factored. It is the single terms. I don't have to necessarily rewrite it. I can recognize that the degree of the denominator, the largest exponent on x in the denominator, is also 4. Since these degrees are equal, we will have a horizontal asymptote. The end behavior is a horizontal asymptote. When you're far away from the origin, it will be the line y equals, because we always need to give an equation, and we need to determine the leading coefficient. Well, the number that's in front of the x to the fourth here is 6, and the number in front of x to the fourth here is 2, and 6 divided by 2 is 3. So I claim when we go to look at the graph that when you're far away from the origin, that if this is the line y equals 3, that when x is going to negative infinity, this graph is going to be real close to that line. Either from above or below, it's going to be getting closer and closer. Now, right now, I don't know how it's going to approach it. And again, as x is going to positive infinity, this graph is going to be getting closer and closer to this line. It might be getting closer to it from above, or it may be getting closer to it from below, but I know it's going to get closer to it. Now, in the middle, close to the origin, it can even cross it. I don't even know what's going on here, but I know that when you get way out there, this is going to level off. And I know it's going to level off. I just don't know. Like I say, here I'm assuming it's coming from below, but I really don't know that. So let's go and check and see if this is correct, this horizontal asymptote of y equals 3 for problem 3. So I've keyed it in already. Let's turn off our answer from problem 2, turn this one on, and you can see, let's come in and graph the line y equals 3, and let's hit the settings up here, the edit, and make that a dashed line because it's really not part of the graph, to illustrate that our graph is, and you can see, let's zoom in, you can see that close to the origin, the curve does cross that horizontal asymptote, but as you get far and farther away, it won't. This blue line is getting closer and closer to that dashed line of y equals 3, and it's coming at it from above, but it's becoming more and more horizontal. It's almost has a slope of 0, just not quite. And over to the right, the same idea is going on. Let's go back to close to the origin here. Now, it looks like here that we're coming at the graph from below. But as it comes from below, it's getting closer to that dashed line. It's getting closer to y equals 3. These y coordinates are probably, 2.9 and then 2.99, and it's just going to keep getting closer. Look at that y coordinate, 2.954. It's almost 3. Well, it's never going to quite equal 3. It's just going to keep getting closer and closer and closer. 2.975, getting closer to 3. So that's what we thought. So we were correct in that our graph was approaching this line. On the right, it was coming at it from below, and on the left, it was coming at it from above. But out in the tail areas, when x is very far away from the origin, then our graph was getting more and more like a horizontal line. So I hope that helps, and I will talk to you later.